Somewhere right now, 640 light-years from Earth, droplets of liquid iron are falling from an alien sky at terminal velocity. Not water, not acid, pure molten metal raining down through clouds that would vaporize a spacecraft in milliseconds. This is WASP-76b, a planet so extreme it forced astronomers to completely rethink what weather means. We thought we understood planetary atmospheres. We thought we knew what was possible. But this world breaks every rule we wrote. How does iron, the stuff of bridges and skyscrapers, fall like a summer storm? For decades, we assumed planets came in familiar flavors. Rocky worlds like Earth, gas giants like Jupiter, maybe something in between. Then we started finding hot Jupiters, massive worlds orbiting so close to their stars they complete a year in days. WASP-76b is one of these. It orbits its star in just 1.8 Earth days. So close that one side permanently faces the stellar inferno. Think about that. One hemisphere locked in eternal day, the other in permanent night. The day side reaches temperatures of 2,400 degrees Celsius. That's hot enough to vaporize iron, not melt it, vaporize it. Iron atoms drift through the atmosphere like water vapor drifts through ours. In 2020, astronomers pointed the espresso instrument at this world. They were looking for iron in the atmosphere. They found it. But here's where it gets strange. They only found it on one side of the planet. Here's what happens on WASP-76b. On the day side, temperatures are so extreme that iron exists as a gas. Individual iron atoms floating in a hellish atmosphere alongside vaporized sodium, magnesium, and calcium. The whole planet is basically a cauldron of metal vapor, but the planet rotates. And as that iron-laden atmosphere sweeps toward the night side, something dramatic happens. The temperature drops by over 1,000 degrees in just a few hundred kilometers. Picture this. You're an iron atom drifting at the terminator, the border between day and night. Suddenly, it's cold enough for you to condense. You grab onto other iron atoms, you become a droplet, and you fall. Iron rain, not a metaphor. Actual droplets of liquid metal plummeting through an alien sky. The droplets are probably tiny, maybe a millimeter across. But they're falling at incredible speeds through an atmosphere denser than anything on Earth. Wait, if this iron keeps falling, where does it go? The droplets descend deep into the atmosphere where temperatures rise again. They revaporize. Winds carry them back to the day side. It's a cycle, an eternal iron-water cycle made of metal, which leads to the part that most people never hear about. WASP-76b isn't just a curiosity, it's a laboratory. For the first time, we can study atmospheric chemistry at temperatures that exist nowhere in our solar system. And what we're learning is unsettling. We assumed weather required water. We assumed rain required conditions at least somewhat Earth-like. We were wrong. Weather is just physics, heat differentials driving circulation, phase changes creating precipitation. The ingredients don't matter. Iron works just as well as water. This means alien worlds could have weather cycles we never imagined. Titanium rain, corundum hail, that's sapphire and ruby falling from the sky. Some theorists suggest the hottest planets might have clouds of vaporized rock that rain liquid lava. The universe has been running these experiments for billions of years. We're just now learning to watch. WASP-76b is 640 light-years away. That's close, cosmically speaking. Close enough to study in detail. And it makes you wonder, if this level of strangeness exists right in our neighborhood, what's happening in the rest of the galaxy? So the real question is, does this change what we think is possible? Right now, the James Webb Space Telescope is turning its infrared eyes toward ultra-hot Jupiters like WASP-76b. The goal: map temperature variations across entire hemispheres. Track wind speeds in real time. Watch the iron cycle in action. Teams at universities across 3 continents are fighting for observation time. Every hour of JWST data is precious, and they're using it to build the first true weather maps of alien worlds. Meanwhile, ground-based instruments are getting sharper. The espresso spectrograph that found the iron is being upgraded. Future extremely large telescopes will let us detect trace metals we can't see yet. Some researchers are losing sleep over a specific question. What happens at the boundaries? Where does iron rain turn back into iron vapor? Understanding that transition could teach us about atmospheric dynamics we can't replicate in any lab on Earth. The data is coming, faster than most people realize. So picture it again, iron rain falling through an alien twilight, but now you understand what you're seeing. A planet caught between fire and darkness, metals cycling endlessly between vapor and rain, weather unlike anything we evolved to imagine. The universe isn't just stranger than we thought. It's stranger than we were capable of thinking until we looked. Here's my question for you. Do you think iron rain is the weirdest weather we'll ever find or just the beginning? Drop your prediction in the comments. Follow for more, we post every week.